Recursion. What is recursion? Recursion is methods passing smaller sections of data to children versions of itself. Why recursion? It's simple, it's elegant, and it's a natural fit for some problems. Consider the following code. Here we have a Java class and a binary search method. Binary search is most often in a recursive form because it is elegant and it's simple. Now, if we want to visualize what this method does, we can look at it like this. Here we have an array of some amount of elements with some value, and we are searching for target 2. Now, obviously, to our smart human eye, we know that target 2 is at index 1 in the array. Now, unlucky for us, computers don't think that way. So we must first sort the array. Now, you may be wondering, oh, if we're going to sort the array, why can't we just search through the entire array first and find the target that way? Well, yeah, if you only need one target once, that's a good idea. However, if you need to constantly search your data for certain elements, it's best to just have it sorted to begin with. So here we have the sorted array, and we're still looking for target 2. Now, what binary search will do is cut it in half. Look at the middle. Is the middle equal to 2? Here we can see 5 is not equal to 2. It's actually greater than 2. And because this is a sorted array, we can cut off the entire array from 5 and above, moving our middle to now 2 and the amount of elements to 3. We can now see that 2 does equal 2. Hooray! We found our target. Practical examples of recursion are divide and conquer. What we just did, we divided the array into 2 parts and we conquered the one part, right? Because we found out we can disregard every other element in the second half of the array. This form of search is log n, big O log n, which means it's very fast. Tree/graph traversal. If you're working with a binary tree, it's inherently recursive. You can do iterative approaches, but it's always going to be more complex than a recursive search or a recursive algorithm. Pathfinding, that relates to tree and graph traversal, and backtracking. It's real easy to return when not to use recursion, when performance is critical and depth is too high. Every time you call a method, it adds it to the stack. And for example, Java has a limited stack size. So eventually you might come to a stack overflow. That's also why it's very important to have a base case in your recursive methods, just so there's a way to break the recursion. Same way your iteration has some logical means of breaking through the loop, some conditional statement, right? And when an iterative solution is more efficient. Closing thoughts. Recursion and iteration are both very important, and anything you can do recursively, you can do iteratively, but it's always going to look ugly if it's meant for recursion or if it's meant for iteration and you do it in the other form. It's always going to be a little more complex. Thanks so much for watching.